In this video, we're going to look at simplifying complex fractions. A complex fraction is a rational expression with a fraction in the numerator, the denominator, or both. So basically, you have a fraction. That's what they're talking about, this rational expression here. And within that fraction, you have another fraction. So the term complex fraction is actually quite appropriate. Let's look at an example of what a complex fraction would look like. So let's say this is my main fraction bar, and in the numerator of this fraction I have 1/2 plus 1/3, and in the denominator of this fraction I have 2/3 plus 1/4. So that's an example of a complex fraction, because within the main fraction the numerator has fractions and the denominator has fractions. So like it says in the definition, it could be just one, either the numerator or the denominator, or possibly both. So there's two different methods to simplify a complex fraction. Let's look at method 1 here. And that method is just going to be to simplify the numerator and the denominator. Simplify, I'll just write top and bottom. And we're just going to go at it sort of straightforward. Okay, so let's say we look at the top and we have 1/2 plus 1/3. Well, we can do that. We'll get a common denominator, which is 6. So we'll multiply that by 3/3 and 2/2. So now I have 3/6 plus 2/6, which gives me 5/6. And in the denominator, I have 3/4 plus 1/2. So my common denominator is 12. I'm going to multiply those, and that gives me 8/12 plus 3/12, which is 11/12. So now for the numerator I have 5/6, and the denominator I have 11/12. Alright, well, what is this saying now? This is saying 5/6 divided by 11/12. Another way to write that then would be 5/6 divided by 11/12. And now you just divide fractions like you normally do. Change that to a multiply, flip over the second fraction, see if there's anything you can cancel. This looks good here. Do that. And multiply straight across. Looks like we're going to end up with 10/11 as our answer. So that is a pretty straightforward way to do it. Method 1, simplify the top and bottom. I guess that would be the first step, and then the second step would be to divide, because when you have this fraction bar here, that's basically meaning to divide. That's sort of a just go at it straightforward method. Take one little chunk, simplify it, take another chunk, simplify it. Alright, nothing too fancy going on there. Let me show you another method, which is going to be a lot easier when we get to more complicated type problems that maybe have some variables in them and some factoring involved. So this second method, we'll call it method 2. Let's method 2. Okay, so let's say we have, let's see if I can remember what I just did here. 1/2 plus 1/3 over 2/3 plus, what did I have down here? 1/4? I think I had 1/4. Well, we'll do it and see if it comes out. I'm pretty sure that's what I had. Alright, so method 2, you're going to find the least common denominator of the fractions that are in your numerators and your denominators. So in other words, I'm going to look at, do I have any fractions in my numerator? Yes, I do. I have 1/2 and 1/3. So my denominators here, I'll just circle them, are 2 and 3. Okay, and now I look at the big denominator of my big fraction. Look at the fractions in there. Do I have any denominators? Yes, I do. I have 3 and 4. So when I say find the least common denominator, I mean of the fractions in the numerator or the denominator. Of the fractions in the top and bottom. Not of the whole big fraction, but the top and bottom. Okay, so now what's the least common denominator of those? 2, 3, 3, and 4. The smallest number they all go into is 12. Alright, so what are we going to do with that 12? Well, what we're going to do, second step, is we're going to multiply the top and bottom of the main fraction by the least common denominator. So we're going to multiply the top and bottom by 12. So here's what that might look like. Big old 12 over 12. 12 over 12. We're going to multiply the top by 12 and the bottom by 12. Now, why is that legal? Alright, what is this big 12 over 12 right here worth? How much is that worth? That's worth 1. 12 divided by 12 is 1. We're basically multiplying our problem by 1. That's always legal to multiply by some form of 1, because when you multiply by 1, you don't change the value of your answer. Alright, so that's why we can do this here. Notice there's no equal sign in this problem. We're not multiplying both sides of something by 12, which is also legal when you have an equation. This is not an equation, it's just an expression, and then you have to multiply the top and bottom. Okay, so if I'm going to multiply the top by 12, I'm going to take 1/2 plus 1/3 times 12. So basically, I'm going to have to take that 12 and multiply it by each thing in the numerator. And then I'm going to take 12 and I'm going to multiply it by each term in the denominator. I'm going to rewrite this so it's a little less messy. Alright. So what we're doing now is we're going to multiply 12 times 1/2, so I'm going to put the 12 here now. And 12 times 1/3, so I'm going to multiply that by 12. 12 times 2/3, and 12 times 1/4. Now you can just start off and write it this way. When you multiply the top by 12 and the bottom by 12, you're multiplying every term by 12. Okay, that's another way to think about it. Well, let's see what we get. We can cancel this 2 with this 12. That gives me 1 and 6. That green's a little light. Let's go darker green. 1 and 6. And then I can cancel this 3 with this 12. That gives me 1 and 4. Then I'm canceling here. Cancel here. And let's see what we've got. What do we have? Well, on the top, we've got 6 times 1 over 1. That's just 6. Plus 1 times 4, which is 4, over 1, which is just 4. On the bottom, 4 times 2 is 8 over 1. That's just 8. And 3 times 1 is 3 over 1 is just 3. Wow, look at that. 6 plus 4 over 8 plus 3. Can't get much easier than that. And looks like I did remember the right problem. We came up with the same answer, which was 11 over 10. So you can see this method is actually faster. It's a little bit weird to get used to at first, but it is faster. You find the least common denominator, and then you multiply the top and bottom by that least common denominator. Now, because it's the least common denominator, it's going to end up canceling out all of these denominators within your fraction, so it's going to get rid of the complex part. It's just going to turn it into a fraction, and then from there it's usually pretty easy to simplify. Alright, let me show you another example that's got some variables in it, and we're going to just focus on method 2. So I'm going to go ahead and well, I'll leave that there. I think I have enough room. Okay, let's look at 3 over m minus m over 3 minus m squared over 4. Okay, here's our main fraction right here. So we want to look in the numerator. Do we have any fractions in the numerator? Yes, we do. We have 3 over m. So there's my denominator. Remember my first step here, I'm trying to figure out my least common denominator of the fractions in the top and the bottom. So I need my least common denominator of m and whatever denominator I have in the bottom, which is 4. So what's the least common denominator of m and 4? Well, that would just be 4m. Just multiply them together. So step 2, we're going to multiply the top and bottom by 4m. Now we have to multiply every term by 4m. So on the top, I'm going to multiply 4m by 3 over m. I also have to multiply this m by 4m. And on the bottom, I just have one term, this fraction here. There's 2 terms in the numerator, but it's just one fraction. And I'm going to multiply that by 4m. Okay, let's see what happens. We're going to cancel now. So this m is going to cancel with this m. Now nothing cancels here because there was no fraction. And in the bottom, the 4 cancels with the 4. Let's see what we have left. In the numerator, we've got 4 times 3 is 12 minus m times 4m. Well, that's 4m squared. What do we have in the bottom? We have 3 minus m squared times m. This 3 minus m squared, that's a binomial. If we're going to times that by m, we'd have to distribute the m in there. But actually, what I'm going to suggest is that you just leave them factored. And I'll show you why here in a minute. So we're going to leave it like that. And as a matter of fact, I'm going to suggest now in the numerator that we see if we can factor that. Because, I mean, we could say we're done here. But with any fraction, you have to see if you can reduce it. And you've probably done a section before this where you learn how to reduce rational expressions. And you do that by factoring. So we need to look in the numerator and see if there's anything we can factor. And hopefully you see that the 12 and the 4 have a common factor of 4. So we want to take that out. So what do we have left? Let's see. 12 divided by 4 is 3 minus, take that 4 out, and we have m squared. Remember, you can check this by distributing the 4 back in. You should end up with what you started with. It's sort of like backwards distributing when you're taking out the greatest common factor. So in the numerator, we have 4 as a factor and 3 minus m squared. Wow, look at that. We have a 3 minus m squared in the denominator. How about that? Then we can cancel these factors of 3 minus m squared. And what do we have left? We have 4 over m. So that's our answer, 4 over m. Let's go ahead and add a couple more steps here. So we're going to find our least common denominator. We're going to multiply the top and bottom by the least common denominator. And then we should, of course you're going to cancel when you do this multiplying, but let's add to reduce. Reduce a fraction, or simplify the fraction. Reduce / simplify fraction. That's the last step, and that's not a trivial step, especially when you've got factoring involved. And as these complex fractions get more complicated, there's more possible factoring that could be done. Let's look at another example. Examples, examples, examples. Get a little more complicated. I think I've got 2 more to look at. Maybe this one might be one where you can give it a shot. Let me write this down. 1 over 9 plus, no, let's go minus, erase, minus 1 over m squared over, all over, 1/3 plus 1 over m. You might want to pause this and give this a try and see how you do. That's always a good way to find out where you're at. Alright, so our first step is to find the least common denominator. And our denominators are 9, m squared, 3, and m. Well, the least common denominator between 9 and 3 is 9. 9's the smallest number they both go into. And when you have an m and an m squared, the least common denominator is always the one with the biggest exponent. So it's going to be m squared. Another way to think about this is that you could cancel what's in these denominators with your least common denominator. So a 9 is certainly going to be able to be canceled because there's a 9 in there. An m squared is going to be able to be canceled because there's an m squared. The 3 is going to be able to be canceled because there's a 9. The m is going to be able to be canceled because it'll cancel with one of these m's in the m squared. Everything has to be able to be canceled. That's what makes it a common denominator. Now, if this is the smallest thing where that happens, then we have the least common denominator. Alright, let's do the legwork here. So I left enough room. So we're going to multiply everything by 9m squared, 9m squared, 9m squared, 9m squared. Now we cancel. As I said, 9 and 9 will cancel, m squared and m squared. 3 goes into 9 3 times, and m goes into m squared is just going to leave an m. Remember, m squared is m times m. So we're canceling one of those m's. That's going to leave an m. In the numerator then we have m squared minus 9. 9 times 1 is 9. And in the denominator we have 3m squared. 3m squared plus 1 times 9 times m is 9m. So now we're on the reduce or the simplify part. We have to see if we can factor this. Well, hopefully you recognize the numerator as the difference of two perfect squares, m times m and 3 times 3 with a minus. So when you have the difference of two perfect squares, you ask yourself what times itself is m squared, that's m and m. What times itself is 9, that's 3 and 3. And then one needs to be a plus and one needs to be a minus. It doesn't matter the order. If you FOIL this out, you'll get m squared minus 9. If you're having trouble with the factoring, you might want to go back and watch some factoring videos or do some review on factoring. In the numerator, we have a common factor. We've got two terms, but it's not the difference of squares because there's a plus there. It has to be a minus. You really always want to look for a greatest common factor first. And I can see both these have a 3 and both these have an m. So I could take out a 3m, which would leave me an m for the first term and a 3 for the second. If I distribute the 3m back in, I get what I started with. Is there anything I can cancel? Looks like I can cancel these m plus 3 factors. Now, I would always see people canceling on a test or a quiz or something, these m's right here that are left. You can't do that. This m minus 3 is a factor. It could only be canceled with another m minus 3. You can't cancel this 3 on the bottom with this 3 on the top because this 3 on the top belongs with this m as part of its factor. You can only cancel factors. The m minus 3 is a factor, so it can only be canceled with another m minus 3. Now this 3 on the bottom is itself a factor, and this m on the bottom is itself a factor. So if there was a 3 or an m on top that was just by itself, not added or subtracted with something, you could certainly cancel it, but in this case, this is going to be our final answer. Alright, let's look at one more example. I know this is getting kind of long, but the more examples, the better. That's what I always say. Okay, especially if these examples are different and they show us some different kind of things that we're going to see. And this one is definitely different. Alright, let's do 5 over x plus 3 minus 1 over x minus 1 all over 2 over x plus 2 plus 3 over x plus 3. So, the least common denominator for this thing is a little more complicated. So our denominator here is x plus 3. That means we're going to need a factor of x plus 3 in our least common denominator. Here we have an x minus 1, so we're going to need an x minus 1. We have an x plus 2, so we're going to need an x plus 2. And we have an x plus 3, so we're going to need an x plus 3, but we already have one, so we're good to go there. So that's it. That big old thing there is your least common denominator. Pretty crazy, huh? So we need to multiply each of these fractions by that big thing there. Oh boy, this is going to be a lot of writing, huh? Okay, here we go. X plus 3, x minus 1. If you think you have an idea on how to do this, good idea to pause the video and go after it yourself and then watch and see how you did. That's always a good way to learn. See, I can talk about that while I'm writing to take up space. Now some of you might be saying, isn't there an easier way? Well, you could take some shortcuts on how to write this out, but sometimes shortcuts on writing get you in trouble. That was kind of messy. Let me rewrite that. X plus 2. Okay, here we go. Next step is to cancel. We're going to cancel this x plus 3 with this x plus 3, x minus 1, x minus 1, x plus 2, x plus 2, x plus 3, x plus 3. Now the multiplying we have left to do is, again, not trivial. We have a lot of simplifying left to do here. We have to do x minus 1 times x plus 2 and then times that by 5. Wow, we have a lot left to do here. Okay, here we go. We can do it. So I'm going to do multiplying the binomials first and then multiply the 5 in, and I'm going to do the same thing on all these other ones. So, and I'm going to go ahead and simplify this middle term. Well, I'll write it out. What the heck. Okay, here we go. X squared, I'm doing FOIL up here, plus 2x minus 2, and I still have to take that whole thing times 5, minus 1 times, I'm going to FOIL x plus 3 and x plus 2, x squared plus 3x plus 2x plus 6. Now in the denominator, I'm going to FOIL x plus 3 and x minus 1. I hope I'm not making any little mistakes here. Kind of going fast. It's okay. Alright, plus FOIL those two. Well, I got my 3 there. Don't forget your 3. So I get x squared plus 2x minus x minus 2. Alright, let me look at this real quick and make sure I didn't do any mistakes with any signs or anything. That looks good. That looks good. Okay, so now we need to simplify and distribute. I'm probably going to have to erase something. Okay, here we go. So, oh boy, let's distribute the, distribute, can we distribute and simplify at the same time? Are we okay with that? Let's do that. We can do it. We're going to do 5x squared, so now I'm distributing the 5 in there. So then these two are going to go together, right? 2x take away x is just 1x, times that 5 would be 5x, and then minus 10. Okay, so now here I'm going to distribute a negative 1, so that gives me negative x squared. Those two are going to go together to make 5x. Distribute the negative 1 makes negative 5x, and negative 1 times 6 is negative 6. Now in the denominator, I'm going to distribute the 2, so that gives me 2x squared. Combine those gives me 2x. Distribute the 2 gives me 4x minus 6 plus 3x squared. Combine those gives me 1x times the 3 is positive 3x, and 3 times 2 is 6. Okay, I'm starting to see the light at the end of the tunnel here. Let's combine like terms in the numerator. 5x squared take away 1x squared is 4x squared. 5x take away 5x, those drop out. And negative 10 take away 6 is negative 16. On the bottom, we have 2x squared plus 3x squared is 5x squared. 4x plus 3x is 7x. And minus 6 is minus 12. Alrighty. Last thing we have to do is see if this can factor. Now I know the numerator is going to factor. That's the difference of squares, and there's a common factor of 4. Let's go ahead and write this up here. So in the numerator, I could take a 4 out, and that'll leave me x squared minus 4. That's from here. Maybe I'll write that down here. So 4 and x squared minus 4. Let's do that, and then we'll use this space up here in a second. Now the denominator, actually before I talk about the denominator, the numerator could factor one more time, right? This is the difference of squares in here. So now I'll write it up here. We have the 4 on the outside, and then x squared minus 4. X times x is x squared, and 2 times 2 is 4. So 2, and then a plus 2 and a minus 2. Okay, now to think about whether the denominator factors, we have what I call a tough trinomial, and I would describe how to factor this in my video factoring using the AC method. So if you need to review that, you might want to go check out that video. Factoring trinomials using the AC method, I think is what it's called. So let's write this up here. This is not an easy one to factor necessarily. This is a long problem, huh? This is a crazy one. You can see how from the ones we did at the beginning, how they can get really tough. So to see if this factors, we take 5 times negative 12. you take, this is the A and the C part. Again, I'm not going to explain the whole deal, but go watch that AC method video. That gives you negative 60, and then you need to ask yourself, will anything multiply to give negative 60 and add to give your middle coefficient, which is a positive 7? So it'd have to be one positive and one negative. I guess it's 5 and 12, isn't it? Because that would give you 7. So it would be a negative 5 and a positive 12. Negative 5 plus 12 is 7. And 5 times 12 is 60, and you got a negative. So then you take these two numbers and you split apart your middle term. Negative 5x plus 12x minus 12. So see, I split the 7x up into negative 5x plus 12x using these two numbers. And then I factor by grouping. Now again, this whole factoring thing is a whole nother skill. And if you need to review factor by grouping, I'm sure you could find a video on that. So group the first two, group the last two. What can I take out of the first set of parentheses? Well, I can take out a 5x, and that's going to leave me x minus 1. And what can I take out of the second parentheses is 12, and that's going to leave me an x minus 1. So then I can take out the x minus 1. You know you've done factor by grouping, right? If those two are the same. And that leaves 5x plus 12, which is kind of disappointing because when I write it over here in my main problem, there's nothing I could cancel. Usually when you factor, you're kind of hoping there's something you could cancel. But that didn't happen for us. So there it is. I'm just making sure I didn't miss a sign issue here. I don't think I did. So that would be the final answer if nothing cancels. That would be it. Well, I hope this video was helpful. I know that last problem was a doozy, and you're probably not going to see too many that are that difficult, but I just wanted to show you one. And hopefully you remember this method of multiplying by the least common denominator.